So what we're going to do here is we're going to rationalize the denominator, which means making the denominator a whole number. And this allows us to know what partitions that we're going to be using as our denominator, whereas the radical is a little bit complicated to do that way. So basically we want to make the denominator whole. So if we were to do this, square this, and that would make this into 2, that would be great. It's a whole number. We square this, I've seen people do this, but this is not correct because what we've done is we started out with this number 3 over root 2 and we squared this number. Well, that's going to give us a totally different number. Okay, so we don't want to do that. So we want to be able to keep this number numerically the same. So to do this, what we want to do, and at the same time get rid of that square root, is what we're going to do is we're going to multiply the denominator by root 2. Okay. Well, in doing so, we're going to end up with the whole denominator of 2. Now, if we're going to do that, we need to balance this ratio, okay, with another root 2 on the top. So I'm multiplying the top and the bottom by the same amount. Okay, well, that means that if I do times and divide, I'm just basically end up with what I started with. So I'm going to end up with the same number here. And another way to look at this is I've multiplied this original number by 1, so the resulting number is also going to be the same number. So now I've rationalized the denominator, and this number in its rationalized form is going to look like that. Okay, so when we test it on a calculator, this number here and this number here are exactly the same. So here is a situation where we have a binomial denominator. So how do we rationalize a binomial denominator? Okay, now this poses a problem if we use the same strategy as before, because if I multiply the bottom by root 2 and the top by root 2, that's perfectly okay, but notice what happens to the denominator. I multiply there, I get 2, but when I multiply there, I get root 2, and all I've done is move the radical from one term to the other. So I haven't rationalized the denominator. Okay, so I need a different strategy. So this strategy involves what we had just talked about here of using a conjugate. Okay, because a conjugate, when I have a binomial radical, the conjugate allows me to get rid of the square root by having a squared and squared term. So this is what I'm going to do. I'm going to multiply this by its conjugate. Okay, so if I multiply the denominator by the conjugate value, 1 minus 2, I have to balance the fraction with doing the top. In the denominator, I'm going to end up with 1 plus root 2 minus root 2 minus root 2 times root 2 is 2. So what ends up happening is these two terms cancel out. I end up with a rational number in the denominator. And although I don't have I have the radical in the numerator, that doesn't matter because we only want to have rationals in the denominator. So I end up with 2 minus 2 root 2 divided by 1 minus 2 is negative 1. So I'll just move the negative up top and make that into negative 2 plus 2 root 2. So we'll use the same strategy here. We're going to multiply the bottom by 3 minus root 2. There's my conjugate. I have to do the exact same on the top to make sure that I don't change the original fraction. I'm going to just skip a step here because I know that when I multiply out the denominator with a conjugate, I ended up with 3 squared minus root 2 squared, which is 2. And then I can multiply at the top. I have to remember to use FOIL. So first, it's going to be 6 outside minus 2 root 2 minus 3 root 3. Negative times negative is positive. Root 3 times root 2 is root 6. Okay, and There are no like terms here, there are no radicals to simplify, so then I just leave the numerator. There's 4 terms in the numerator, and my denominator now becomes a rational number of 7. Okay, so there it is. So this number here, when I put this in my calculator, will be exactly the same decimal value as that number there.